Hello dear friends, let us start theoretical portion, unit 1. We already seen practical based on homogeneous differential equation, non-homogeneous differential equation, linear differential equation and Bernoulli differential equation. We already seen 4 practicals. એટલે કે ટૂંકમાં in short problem based on that standard forms. But see, as far as homogeneous and non-homogeneous differential equation is concerned, that thing already seen in 12th science, so right now we are not going to see it. Same time, we already seen that variable separable form also already seen in 12th. How to find order and how to find degree of differential equation, that thing is also seen in 12th science. Right now, we are going to start theory section. Now see here, state and prove. Theorem number 1. State and prove. Linear differential equation. State and prove linear differential equation. Is the null form of linear differential equation is dy by dx plus py is equal to q, where, say result number 1, where p and q are functions of x only. Clear? This is the statement. Now prove. Prove. Here, there is no need to give equation number 1 there. I am here taking 1. For consider right hand side 0. See, one question is why we are taking right hand side is equal to 0. This is the procedure. This is the theory section. So keep thinking into mind. To get the standard form, we have to solve various parts, or we have to move through various concepts or various forms to derive that thing. So this is when I am taking this one as a 0, and therefore dy by dx is equal to minus py, and so variable separable form, can we write in this way? Yes. Integral dy by y is a minus sign common integral p dx. Why I am not taking p common? Because p is not constant quantity, so we can't take it common. Plus, let us put log mod c, because one of the integral in terms of log. So log mod y is equal to minus integral p dx plus log mod c. Take integral part on left hand side, log y on right hand side. So integral p dx is equal to log mod c minus log mod y. Therefore integral p dx is equal to log mod c by y. Let us put reason here. Log x base a is equal to y if and only x is equal to a raised to y. Here base is e is given, so e raised to integral p dx is equal to c by y, and therefore y into integral e raised to p dx is equal to c. Now differentiate with respect to x. So what we get? D by dx of y integral e raised to p dx is equal to 0. Now differentiate this thing. Y as it is, derivative of this one, integral e raised to p dx into d by dx of integral p dx plus e raised to p dx as it is, derivative of y dy by dx is equal to 0. Yes or no? Yes. Now see here. Now this from this one, integral part is given, p is function of x only. And if we differentiate it, we get original function. So that is p. So py e raised to integral p dx plus e raised to integral p dx into dy by dx is equal to 0. We can write that thing here. If I take e raised to integral p dx common, what we get? Dy by dx plus py is equal to 0. So can I write d by dx of y raised to integral p dx is nothing but this one? Yes. Integral p dx into dy by dx plus py, because derivative of this one is this thing. Now, according to given equation, what will be this thing? D by dx of y integral e raised to p dx, e raised to integral p dx into q. That is given. So by 1. Now, right hand side in terms of x only, so we can integrate it. Therefore, by integrating on both sides, what we get? Y is equal to y integral e raised to p dx is equal to integral q into integral e raised to p dx whole dx plus c. Here is a solution and is solution of 1. Here e raised to integral p dx is called integrating factor of equation 1. That is if is equal to integral e raised to p dx. If is equal to integral e raised to p dx. And therefore solution is y into if is equal to q into if integrating factor dx plus c. And we already use this form to solve practical problems. And see, this is the result based on linear differential equation, theorem number 1. Now let us see second result, state and prove or state and solve. See, state and solve. આગળનામાં મેં શું લખ્યું છે? સ્ટેટ એન્ડ પ્રૂવ કરેલું છે. કરેક્શન કરજો. સ્ટેટ એન્ડ સોલ્વ થિયરમ નંબર 2. સ્ટેટ એન્ડ સોલ્વ બર્નૌલી differential equation. Clear? See, a general form of Bernoulli's differential equation is dy by dx plus py is equal to qy raised to n, where n belongs to R and p comma q are functions of x only. Clear? So here dy by dx plus py is equal to qy raised to n is given. Now divide this equation by, therefore y raised to n minus n dy by dx plus p y raised to 1 minus n is equal to q. Say equation number 1. Clear? Now take y raised to 1 minus n is equal to substitution. Suppose y raised to 1 minus n is equal to z. Let us consider that is equal to z. So if we differentiate it, 1 minus n y raised to minus n dy by dx is equal to dz by dx. So y raised to minus n dy by dx is equal to 1 upon 1 minus n dz by dx. And therefore by 1, what we get? 1 upon 1 minus n dz by dx plus p into z is equal to q. So multiplied by 1 minus n. So dz by dx plus 1 minus n into pz is equal to 1 minus n into q, and is linear differential equation in Z, and therefore its solution is Z into if. If so say e raised to 1 minus n p dx is equal to 1 minus n q e raised to integral 1 minus n p dx whole dx plus c as per linear differential equation. Now what is value of z? Put value of z. Therefore y raised to 1 minus n e raised to integral 1 minus n p dx is equal to integral 1 minus n q e raised to integral 1 minus n p dx plus c. And this is the solution of Bernoulli differential equation and is a solution of equation 1. બરાબર. આ બે રિઝલ્ટ પ્રૂવ કરી દીધા આપણે. કયા? તો કે લિનિયર ડિફરન્શિયલ ઇક્વેશનવાળો પાર્ટ આપણે પ્રૂવ કર્યો. હવે જોવું છે આપણે નેક્સ્ટ વેરી ઇમ્પોર્ટન્ટ રિઝલ્ટ. And before that one definition. Exact differential equation. A differential equation can be obtained on direct differentiation of its solution. Then, or if differential equation can be obtained from on direct differentiation of solution, then it is said to be exact differential equation. Said to be exact differential equation. ક્લિયર? આ એની ડેફિનેશન છે. હવે મિત્રો આપણે એક જોઈએ કામ જોઈએ કે before that result we need some concept of differentiation. So I would like to put as a note. See, if some function y is equal to fx is given, then if we take dy by dx is equal to f dash x is a ordinary derivative. And if some function z is equal to fxy, let us consider 2x plus 2y. If we differentiate with respect to x keeping y as a constant, if we differentiate z with respect to x keeping y as a variable y as a constant, that is del z by del x is 2. Derivative of 2x is 2. Derivative of 2y constant, so 0. Differentiation of z with respect to x keeping y as a constant. Sorry, x as a constant. So it comes out 2. Such a differential equation is called partial differentiation. Clear? Now, consider z is equal to x square plus 2xy plus y square is a function of x and y. Differentiate partially with respect to x. So we have to take y as a constant. So the derivative of x square 2x. Y is a constant, so 2y is constant, derivative of x is 1, that is 2y, and derivative of y square is 0. Clear? And del z by del y, if we differentiate with respect to y, then x square is constant, so 0. 2x is constant, so differentiation of y is 2x plus y square 2y. Now del z by del x is given, differentiate with respect to y. શું આવશે 2. અને differentiate with respect to x, del z by del y. That also comes out 2. So del square z del y del x is same as del square z del x del y. This one is mixed partial differentiation. Clear? First differentiation, that is ordinary differentiation. Second one, partial differentiation. Here just we are taking only simple idea of partial differentiation. In semester 3 we are going to see it in detail. Same time one more differentiation is also there, that is total differentiation. See, that is if z is a function of x and y, then dz, only dz, total differentiation, del f by del x into dx plus del f by del y into dy is a total differentiation. That is dz partial differentiation of with respect to x into derivative of x dx, partial derivative of f with respect to y into derivative of y dy. This one is total differentiation, TD. OD, ordinary differentiation. PD, partial differentiation. Clear? Now we can move up to third result. State in or obtain necessary and sufficient condition. Necessary and sufficient condition. State and prove the necessary and sufficient conditions for differential equation m of xy into dx plus n of xy into dy is equal to 0 to be exact differential equation. Exact differential equation. This is theorem number 3. Clear? હવે જોઈએ ફર્સ્ટ પાર્ટ ઇઝ નેસેસરી પાર્ટ. આ પાર્ટ શું આવે? નેસેસરી પાર્ટ. સપોઝ mxy into dx means m is a function of x and y. nxy into dy is equal to 0 is exact differential equation. We already noted its definition. How we can say that given differential equation is exact differential equation? Clear? Direct differentiation, a differential equation can be obtained on direct differentiation of its solution. Then such a differential equation is called exact differential equation. And therefore we have function fxy such that m dx plus n dy is equal to df. Result number 2. But by total differentiation, df is equal to del f by del x into dx, del f by del y into dy. Say this is 2, this is 1. And therefore by 1 and 2, m dx n dy is equal to del f by del x into dx plus del f by del y into dy. Now compare करिए coefficients. So m is equal to del f by del x and n is equal to del f by del y. હવે એક મિનિટ, મેં પહેલાં કન્ડિશન તો લખી નહીં, આપણે સીધે સીધું ડાયરેક્ટ ડિફરન્શિએશન જ કરવા માંડી ગયા છીએ. સ્ટેટ એન્ડ પ્રૂવ, તો હજી મેં કન્ડિશન સ્ટેટ નથી કરી, બરાબર? સોરી, તો અહીંયા હું સ્ટેટમેન્ટ અલગથી લખી દઉં છું મિત્રો. જોજો હો, પછી પ્રૂફ સ્ટાર્ટ કરવાની છે. આ પ્રૂફ આપણે અહીંથી સ્ટાર્ટ કરીને અહીંથી સપોઝથી, આ સપોઝથી સ્ટાર્ટ કરીશું, બરાબર? તો હું સ્ટેટમેન્ટ અહીં લખી દઉં, આ પેજમાં જ લખી દઉં સ્ટેટમેન્ટ. necessary and sufficient condition for differential equation m dx plus n dy is equal to 0 to be exact is del m by del y is equal to del n by del x. Partial derivative of m with respect to y is same as partial derivative of with respect to x. This is the necessary and sufficient condition. Sorry, huh? હવે પછી આપણે શું કર્યું? Suppose m dx plus n dy equal to 0 is exact differential equation. So we have a function fxy such that this thing m dx plus n dy is equal to direct df મળે. કેમ? તો કે we already noted that the direct differentiation of its solution, a differential equation is obtained by taking direct differentiation of its solution is called exact differential equation, and this is due to total differentiation. By comparing coefficient we get it. So we have to differentiate with respect to y partially. So del by del y of del f by del x. Differentiate partially with respect to x. So what we get here? Del m by del y is equal to del square f del y del x. Del n by del x is equal to del square f del x del y. But we know that mixed derivative are same. But del square f del y del x is same as del square f del x del y. So we get del m by del y is equal to del n by del. Clear? We get this thing. This one. Clear? હવે conversely, આ part. Suppose del m by del y is equal to del n by del x. And our aim is to see that differential equation is exact differential equation. So consider v is equal to, say this is result number 3. Take v is equal to integral m dx, where y in m is constant. આવું લઈ લેવાનું. તો નાવ partial differentiation of with respect to x is same as ordinary differentiation, del v by del x. Now m is a function of x only because we are keeping y as a constant, so we can integrate it, so we get m. Now differentiate with respect to y, del by del y of del v by del x is equal to del m by del y. So what we get? Del square v del y del x is equal to del m by del y. But we know that del m by del y is equal to del n by del x, that is by 3. So del square v del y del x is equal to this one, and therefore del square v del x del y, because mixed derivative are same, del n by del x, and therefore del by del x of del v by del y is equal to del n by del x. Now on integrating on both sides with respect to x only, so del v by del y plus some constant g of y, because we are keeping y as a constant, that is n. What is value of m? Value of m is here del v by del x. And what is value of n? This one. Now take this value in this integral, in this differentiation. Therefore now m dx plus n dy. What is m? Del v by del x into dx, del v by del y plus c of y into dy. This is the value of n. That is equal to del v by del x into dx, del v by del y into dy plus some function gy dy. This is total differentiation dv plus c of y dy. Now consider new function that is equal to dv plus derivative of some function hy, where hy is nothing but integral of gy dy. Consider this one. So we get this thing. So that is equal to v plus hy. So that is df. F is equal to v plus hy. So we have a function f. We have function f such that m dx plus n dy is equal to df. That means we have a function. On direct differentiation of that function, we get given differential equation. Therefore m dx or m of xy dx plus n of xy into dy is equal to 0 is exact differential equation. Today I have already seen three most important results: linear differential equation, Bernoulli differential equation, and then exact differential equation. મિત્રો આપણે થિયરી સેક્શન સ્ટાર્ટ કરી દીધું છે, 4 પ્રેક્ટિકલ પણ થઈ ગયા છે. ઓલમોસ્ટ આ મહિનાના એન્ડમાં આપણે બધું જ થિયરિકલ પોર્શન કમ્પ્લીટ કરી દઈશું અને 80% પ્રેક્ટિકલ પણ કમ્પ્લીટ થઈ જશે. તો મારી સાથે સાથે પ્રેક્ટિકલ જર્નલમાં પણ લખતા આવજો અને થિયરી પણ તૈયાર કરતા રહેજો. એટલે ખાસ આ એક તમને સૂચના છે કે મારી સાથે સાથે રોજ કરતા રહેશો તો કોઈ પ્રોબ્લેમ થશે નહીં મિત્રો. હા, થેન્ક યુ મિત્રો. આપણે નેક્સ્ટ લેક્ચરમાં જોઈશું બીજું.